On these, we're in section 2.1 here in college algebra. You should really do it the way they ask you to because, again, your tests are on paper and your final is on paper. And if it says, please solve this algebraically, please solve it algebraically. That means do the actual work. We will also solve some equations today with the graphing calculator, and there's really no work to do, right? But get yourself in the habit of doing what the instructions say. It says solve each equation given a rational number. So here's an equation. Nasty fractions, right? Let's get rid of the fractions by finding the least common denominator. This is a 4, this is a 6. What's the least common multiple between 4 and 6? 12. Let's take every term times 12 then. That's how I roll, right? I don't like to add fractions together. I don't want to deal with fractions. I'm just going to clear the fraction. Everything times 12, 12x minus. Then, since we picked a multiple of these denominators, it's real simple. Ask yourself, how many times does 6 actually go into 12? That's what division means, is go into. How many times does 6 go into 12? 2 times. Take that times your numerator. 2 times 5 is 10. We already had it negative from that sign right there. You all cool with where that 10 came from? Equals 12 times 3x is 36x. Plus 4 goes into 12 3 times. Take that times your numerator and you get a 3. There you go. No more fractions. Solve for x. Get your x's on one side. Get your constants on the other side. So negative 10 equals 24x plus 3. Subtract 3. Negative 13 equals 24x. And then divide both sides by 24. And it wants a rational answer, not a decimal. There you go. Negative 13/24. If you want to see if that can reduce, you could always punch it into your calculator, negative 13 divided by 24, and then do a little math enter, enter. You ever seen that trick before? Math enter, enter. If you have a decimal, negative 13 divided by 24. If you have a decimal, if you hit the math button, the first thing on there says change it to a fraction, please. So that's why you hit enter. And then they're just bringing you back here, and it's like, is that what you want to do? You hit enter, and it will reduce the fraction for you. Math, enter, enter does that for you. So there you go. And that's your answer. Next guy, let's clear the fractions. What would we multiply everything by? Between a denominator of a 3 and a 4, we multiply by 12 again. Da, 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 da. Having pen problems today. I need a pen pal. Minus 3 goes in there 4 times. 60x. 4 goes into 12 3 times. Add times 9. 2. And then add 36 over. Subtract away the 9. Divide by 96. That would be a mess to use your graphing calculator anyway to try to solve that graphically, because it would just come out as some nasty decimal, right? So algebraically, much nicer, and it really wasn't that hard. You know, you've been doing it for 3 or more years now. You just keep doing it. Clear the fractions. Next guy, decimals. If you want to, you could clear the decimals by multiplying by 1,000, because that's the most decimals you see. It's thousandths, 3 decimal places. Or, since we're just doing it algebraically, why don't you just get all the x's on one side, just keep the decimals in there. So I'm going to subtract 0.023x from both sides and use my calculator. So 0.8 is coming down. And then you get, is that 0.337? Is that right? X. And then add 5.266 over there. And then divide by 0.337. See what that comes out to be for me. Nice nice and neat. 18. Cool. 4. Trying to find the least common multiple between all these denominators. There's a quick and easy way to do it. Find your biggest denominator. Boom. 6. Start counting out multiples of 6. Once you find one that goes into all those numbers, that'll work. See, 6 doesn't work because 5 doesn't go into 6 evenly, right? Next multiple of 6 is 12. 5 doesn't go into 12 evenly. Next, 18. 5 doesn't go into 18. Then the next multiple of 6, 24. That doesn't go in there. The next multiple of 6 is 30. Because all of these denominators go into 30 evenly. So let's clear the fractions by multiplying by 30. I chose my biggest denominator and had multiples of 6 and find the smallest number that went into all of those, and that's 30. So 3 goes into 30 10 times. Take a tangent numerator, and you got a 20. 5 goes into 36 times. Take a tangent numerator, and you get a negative 36, and etc. In basic algebra. Even if they didn't tell me to solve this algebraically, I would totally solve it algebraically, because that would be a pain to type in my graphing calculator. All those fractions, not that easy to type fractions in. Subtracting 15, negative 51, right, equals 5x. And then x equals negative 51 over 5, and that does not reduce. Solving algebraically. Why? Because they told us to. If I had to choose anyway, it really wasn't that hard. Punching that stuff in a calculator, which we'll see how we do that later, not the easiest thing to do. Next one. Find the solutions to an equation of f of x equals 0. Find the x-intercept of the graph, and then find the 0 of the graph. All three things are the same. The solutions to an equation is when y equals 0. Would you agree that that's basically what that says, when y equals 0? F of x is really y, when y equals 0. Isn't the x-intercept when y equals 0 also, correct? And the 0 of the graph is when y equals 0. So we only have to do the work once, and that's our answer for all three questions. It's training you to realize the solutions, the x-intercepts, the zeros, and even the roots all mean the same thing. So the solutions, all you have to do is let f of x equal 0. Isn't this f of x right here? Let him equal 0. All you do is substitute 0 in for y, or substitute it in for f of x, whatever it's written as. Now solve for x. Negative 32 equals 1.6x. Then you can divide that out for me. And you should get negative 20. Let's answer all three questions. Part A, negative 20. That's the solution, right? Isn't that what we got? Isn't that what x equals? That's the solution to our equation right there. Negative 20 was the solution. What's the x-intercept? You just put negative 20. Some people are like, should you put this, negative 20, 0, like as an ordered pair? My math lab doesn't want that. They just want the negative 20. Okay? And then part C, find the 0 of the function. It's negative 20. That's what the x value is that gives you 0 back for y. It's where it crosses the x-axis at. If you graphed it, that would be the x-intercept of it also. Next one, find all three things. You are putting 0 in for y, a.k.a. putting 0 in for f of x. I would get rid of the divide by 4 first by multiplying both sides times 4. It just so happens that 4 times 0 is still 0. And then add 5 to both sides. And 5 is our solution. That is also where this graph would cross the x-axis at if we punched that in. What I'd like you to do real quick is graph that on your calculator. And let's see if you can actually graph it correctly. graph that function on your calculator, and let's just see if we all get the same thing. That's a linear equation right there. Aren't all x's to the first power, all variables to the first power? There's no variables in the denominator. There's no negative exponents. This is the same thing as 1/4 x minus 5/4 right there. And the graph looks like this. But how do you type it in? Those of you that have it different than mine, how do you type this into your calculator? Numerator is a group. Denominator is a group. You must put the numerator in parentheses. You must put the denominator in parentheses. But since there's only one term in there, it doesn't matter. Check it out. Where does it cross the x-axis at? If I do a second, calculate and find the 0, boom, left bound, boom, to the right bound. Where should it cross the x-axis at? At 5. So let's just see. I could have traced 5 also to see what happens. But guess 5, 0 right there. It's the solution, it's the root, it's the x-intercept, and it is the 0 of the function. Cha-cha. Next one, solve these graphically, correct? Solve them graphically. So all they want to know is when this guy, Mr. Red, equals this guy, Mr. Green. I want to know when they are equal. All you do is take the red thing and make that your y sub 1 in your graphing calculator, and take the green thing and make that your y sub 2. So go to your graphing calculator, clear everything out, and let's type the first guy. Whatever's on the left side of the equal sign, let's type him. Let me do this real quick. Do-do-do, do-do-do, do-do-do. I hate that fill the screen thing. 3 times the quantity of x minus 8. Sorry. Problems. X minus 8. That's y sub 1. Let the green thing be the other dude. 5 times the quantity of x minus 4 plus 6. Right? And what we would do is graph them both, and where would they be the same? What would you look for? Where they intersect at. So let's graph them on the standard window, zoom 6. And let's see what happens. Here, they don't intersect in this window. That means you must find the right window. That's why solving these graphically isn't that nice. You've got to find the right window. Would you believe that they'll intersect somewhere down here, though? Correct? So what do we need to change on our window? So x max, y max, x min, or y min? The y min. Let's just go way down yonder, right? Why mess around with it? Let's make our y minimum, I don't know, negative 60. Let's go big, or go home. Y scale, I'm going to change it to go by tens then. All right, let's see if I can find it then. Hit graph. Yes! Thank you for going big. Again, my window, I went the y minimum right here. I just changed it to negative 60, went by tens. So then I graphed it. How do you find the intersection? Second, calculate. Intersection is choice 5. All right, so choice 5. First curve, just hit enter. They're asking you which one do you want. It's like which line do you want. The first one's one of them. Second curve, just hit enter. Guess. There's only 2 curves, a.k.a. these are all your curves, all your graphs. How many did you put in? Just 2, right? So they're asking you to, I got to do it over now. Select which ones do you want. Well, I want the first one and the second one. Guess. It'll tell you it's at negative 5, negative 39. Write that as an ordered pair right here. But what's the solution? If you was to do this algebra, oh, that should be an X, not an S. Sorry, there's a typo there. Right? Both be X's, not, this was an S and that was an X. Sorry. It's good on yours? Okay, my bad. So, if you were solving this, what would you be solving for, my friends? What do you solve for? You solve for x. What's the solution to this? X equals negative 5. All done, right? But we use our graphing calculator to figure that out. Cool? Next one. Let's punch that into the graphing calculator very, very carefully. 3t divided by 4. Whew. 3 x as a quantity divided by 4, cool, minus 2. Remember, you're not typing the whole thing. It's just left side on y1, right side on y2. 5x minus 1 in parentheses. This is way too slow. Divided by 3. Got to get those parentheses in there, sir. Plus 2. And I'm going to go back and zoom 6 it again. We've got that crazy window again, right? So I always just zoom 6 it, but that's how she should be typed in. All numerators, if there's more than one thing up there, you want to put them in a group. So zoom 6. Do I see where they intersect on the zoom 6 window? Yay! I see it, so I will calculate where they intersect. First curve, enter. Second curve, enter. Guess, enter. Boom, -4, -5. So I know that you actually did that. And then the solution is really, don't put x equals -4, it's t equals -4. Use the variable that they used. But what you're finding is the x value of the intersection. Cool. Next guy. Hardest part is finding the windows. So 14x minus 2, 4. 27 minus 3x. Zoom 6 is where we're on. Let's see if that window works. There's one dude. There's the other dude. No way, Jose. What do we need to change to find it? The y max. I'm going to just go way up yonder to 50. Might as well go big. Hopefully that works. I'm changing my scale by 10, so I changed my y max to 50. I don't know if it's going to work or not. I'm just guessing, you know. Then I go back and hit graph. Hopefully I see it. Yes, I do. Then I calculate it. Second, calculate intersection. First curve, enter. Second curve, enter. Guess, enter. They do that because you could have 3 things graphed. You could have 4 things graphed. It's like, which ones do you really want to find the intersection on? 3, 18. And that means that x equals 3. And finally, the last one, it's just typing it incorrectly. So y equals, clear me. X minus 5 is a quantity. That's an entire numerator. Divided by 4. Then you can just put the plus x. And then x over 2. You don't need any parentheses on that. If you want them, you can have them. But there's only one term in the numerator, one in the denominator. Plus 1/3. 1 divided by 3, because your calculator does the order of operations, so it'll do the addition last. You know, it just look like that. If you want to be safe and put the whole thing in parentheses, it won't hurt it. Zoom 6M, see if that works. Yes, it does. All right. Calculate. 5, enter, enter, enter. Oh no! If you wanted the real answer, you could do it algebraically. If you know your decimals very well, you could be cool. 2.1 repeating, 0.111111111. You know what 0.33333333 is as a fraction? It's 1/3. It's really 3/9. You know what 0.6666666666666 is as a fraction? Which is really 6/9. 0.1 repeating, 1/9. 0.2 repeating, 2/9. 0.3 repeating, 3/9. 0.4 repeating, 4/9. 0.5 repeating, 5/9. What's this really? 2 and 1/9. And then 1.38 repeating. We'll just put that because we don't even care about the y value. Isn't it really at 2 and 1/9? That's an exact answer because that was a repeating decimal. If you really didn't know, you could maybe try this. Quit out of it. Just type 2.111111111111111 in there and hit math, enter, enter. Maybe 19/9, which is 2 and 1/9. Cool. because doesn't 9 go into 19 two times, and there's 1 left over. Nice. Solve for the indicated variable. Honestly, something you, as math students, have never been that good at. Get the variable all by itself on one side of the equal sign. Number 11, solving for r going multipliability. R is inside the grouping symbols. Why don't we get rid of this times p first? I don't really want to distribute that p through. Why don't we get rid of the times p by dividing by p? What's left is 1 plus RT. Then, here's the term with the r in it. Is there anything being added or subtracted to that guy? There's a plus 1. Get rid of the plus 1 by subtracting 1 from both sides. Correct? And then we need to get rid of that times t, right? Because we're trying to get r all by itself. Instead of dividing everything by t, do you see how we already have a fraction in this problem? Instead of dividing by t, why don't we multiply by the reciprocal of t, which is 1 over t? If you take everything times 1 over t, that'll be fine. So I'll show you the work on that if you want. I want to multiply everything by 1 over t. Cool. If I multiply, this is a fraction times a fraction. Numerator times numerator, a. Denominator times denominator, p times t is pt. Minus, make this a fraction. Numerator times numerator, 1. Denominator times denominator, t. When you take this times that, isn't the whole reason why we are multiplying by 1 over t to get rid of the times t? This has a times t with it. We're multiplying it by a divide by t. That just turns out to be r all by itself. Next one, solve for h. There's something really ugly in there. Mr. Fraction. I would get rid of Mr. Fraction first. Isn't that a divide by 3? Multiply every term times 3. How many terms are there, though, baby? How many? Just 2. 3 times v is 3v. And this is all one term, because terms are separated by addition, subtraction, or equal signs. That's all one term. The times 3 and the divide by 3 cancel each other out, and you're left with pi r squared times h. Correct? All you're trying to do is get h all by itself. Just one term. Isn't this just a bunch of stuff being multiplied by it? Get rid of the times pi r squared by dividing by pi r squared. H equals 3v over pi r squared. Let's see how good you are. Try number 13 on your own, then you can check back with me. First move is to add 9c to both sides. Second move is to divide every term by 5. I like to do individual terms, especially when 160 divided by 5, really nice. It's 32, right? You can also type it in this way. The whole thing was the red 160 plus 9c all over 5. It'll accept either answer. But I don't know in science class how much you change Celsius into Fahrenheit and etc. You know anything about that number? What's so great about 32 degrees in Fahrenheit? That's freezing, you know, that's why Celsius is like this, that 32, and there's a rate of change of 9/5 between those. Okay, 14, solving for n, real simple. Find the term with the n in it. Is there anything being added or subtracted to that guy? Yes, get rid of him first. So you've got p over 2 plus a and minus 5m equals negative 2n. No like terms whatsoever to combine. Still got to get rid of that times negative 2. Being as how this guy has a fraction in it, and of dividing by negative 2, multiply by negative 1/2, right? The reciprocal. Just multiply by the reciprocal of negative 2, which is a negative 1/2. That way, you have a nice clean thing right here. This is negative p fourths. Y'all cool with where that came from? Minus a over 2 plus 5m over 2 equals n. Signs all changed. Everything twice as big in the denominator as it was before. This is where Math Excel, excuse, I keep saying that, My Math Lab has given you some trouble, the story problems, and it's more about converting than anything. You've got to read the problem for serious details, like, oh, they needed it this way, oh, we needed it that way. So some story times. This building, it cost this much originally, right? Quite a building. It depreciated. That means it went down, right? Its value went down for tax purposes by its owner using the straight line depreciation method. Straight line means it'll be linear rate of change. The value of the building Y, they straight up tell you what Y stands for. That's the value of the building. After X months, they straight up tell you what X stands for, is given by this equation. They straight up give you the equation. After how many years, they want to know after how many years. So years, will the value of the building be this much money, right? They give me the value of the building. Let me use this cool pink color. Ooh, that's pretty. That's the value of the building. See the value of the building right here, the value of the building. Where do I put that big old honker number into? In for X or in for Y? In for Y. Should I knock off some zeros or anything like that? You know, they give me this big number. Do I need to knock off some zeros? Did the equation they gave me have all those zeros in them? Then the number that I put in will have all those zeros. 69000 with commas. I'm just substituting that in for a Y because they want to know how long will it take for that to happen. So I will solve for X. We will subtract U over. You can punch stuff in. A lot of you have just been copying my work. Let your brain do some work by punching stuff in a calculator. Use your brain so you can use your calculator. Divide that out. And what did you get? 60. Discuss with your neighbor. What's the answer? 60. Typical My Math Lab, right? You get X equals 60, you think the answer is 60. I heard you all say they want to know how many years, but the equation is in months, right? Doesn't X stand for months? So this is 60 months. You got to say, well, since there's 12 months in every year, it would take 5 years to get that done. Just because your algebra is right doesn't mean your answer is right. Good deal? That equation was in months. Next. The future value of a simple interest investment is given by that formula. Remember what principal is all about? It's been a while. P stands for principal. That's how much money you put in. So like if you put $10,000 away, that's your principal, right? The principal amount. R stands for the rate. It must always be a decimal that you put into these equations. The rate is always a decimal, but they'll usually tell it to you as a percent, right? T is time, and S is the value of it later, right? So here we go. It says, what principal P must be invested for 5 years at the simple interest rate of this so that the future value is $9,000? Real simple when they ask you a question, what principal? That's what you don't know. You won't know P, correct? So where's the 9,000 go in for? S, P, R, or T? S, P, we don't know. 1 plus my rate says 10%, but you need it as a decimal, so that is 0.1. You can put a 0 after it if you really wanted to, times 5, because it said 5 years. Y'all cool with where I got them numbers from? Let's clean some stuff up. Got to do this first, right here. Isn't that 0.5, correct? Plus 1 more, so you got 9,000 equals 1.5p. Everyone cool with where the 1.5 came from? Then divide by 1.5. The principal equaled how much? And are we done? Was there any crazy converting or anything like that? 6,000 what? Dollars. You got to put in $6,000 for that to have happened. That is a ridiculous situation anyway. That's not how interest works. Next one. Number of cell phone subscribers. Important. What does that say? In millions. Between 01 and 09 can be modeled by this equation, where x is the number of years after 95. In what year does this model indicate that there were this many subscribers? That's a big number. See this equation right here? Did they use a bunch of zeros? Yes or no? No. The equation is in millions, but these numbers right here represent millions, right? They say that. So this mega number, we need to change it back into a decimal so it fits the equation correct. In this, 1 million. All you have to do is take this and divide it by a million if you want to. Do you know how many zeros 1 million has in it? 6. That means that this decimal, which is located right here, moves 6 places this way. 3, 6. Shouldn't the decimal go right there instead? Cool? Moving that decimal, we're putting 311.7 because that really means 311.7 million right there. Solve for x. Solve for x. Sorry for the dragon. Where am I at here? So, subtract over. Ooh, that's nice. 210, right? See if you can do that without a calculator. What's 210 divided by 21? Or don't try, whatever. 10? Answer the question. In what year did they have that many subscribers? 2005. How do you get that? This is years since 1995, so you have to take 1995 and add 10 to it and get 2005, because that's what X stood for. 1995. Woo! It's a good one. I'll let you read it and think about it. Just realize how not so easy they are. Let you read it and think about it. We tried some ideas in class. We had good ideas, but they were just some flaws in them. What don't we know? Like, what would be great if what we did know? What would you really want to know? They ask you about the tax, but what would you really want to know? How much the car really cost without tax? Let X equal original price of the car. Right? If you knew that the original price was X, correct? So we'll do this. Here's the price of the car now. How would you figure out how much it costs? Like if I told you I got a candy bar and I'm going to go buy it, but there's 6% tax that I have to pay. Let's say it costs $1, right? Wouldn't it cost more than $1 in the first place? Boom. Aren't you going to pay 106% of the original price? So we're going to take the price of the car times 1.06. And doesn't that equal how much you totally paid? Correct? Well, do you know how much you totally paid? Pretty sure it's $29,998. So let me start over. You don't know the original price of the car, but you do know you're going to pay 6% tax. You're going to pay the price of the car plus 6% tax, so that's 100% of the price plus 6%, which is a total of 106%. Cool? That multiplied together equals the price of the car. How can we solve for X? Divide by 1.06. 28,300. But what does X stand for again? The price of the car. How much is the tax? You do a little subtracting right here. Here's another way to think of it. This is too much, right? Too much. That's tax and original price. This is more than 100% of the original price right here. So what you have to do is divide by 1.06. Whatever your percent of tax was, you need that plus 1, and you want to divide by that. And that'll give you the original price. There's your tax. There are probably other ways to figure that out. In my opinion, this is the easiest way. Just realize, aha, price equals original price times your tax plus 1. Okay? Last one. If P dollars are invested for T years at a simple interest rate of R euros a day, the future value of the investment is this cool formula. If $2,000 are invested for 6 years, gives a future value of this much, what is the simple interest rate of this investment? Again, finding the question, what is the simple interest rate? What are we going to solve for? A, P, R, or T? We're going to solve for R. So we should know everything else. They tell us P straight up, as in P the dollar, I guess not straight up, but P the dollars invested is in $200,000 invested, so 2,000 is P. You know T in time is years, so A's got to be 3,200. That's the amount that we want. 2,000 plus 2,000 R times 6, which I'm going to switch those around. 6 times R. It's all good in the neighborhood, however you write it. Associative property of, commutative property of multiplication. Move them around. Okay, trying to solve for R. Here's the term with the R in it. Don't we need to get rid of this plus 2,000 first? Subtract 2,000 from both sides, and that would be 1,200 equals, watch this awesome move, 12,000 R. Where did I get 12,000 R from? What's 2,000 times 6? 12,000, right? I multiplied those together. Then you divide that out. 1,200 divided by 12,000. You will get a decimal. What decimal did you get? 0.1. To answer the question, what is the simple interest rate of this investment? That is a decimal. They want the rate as a percent. What is 0.1 as a percent? 10%. Not the easiest problems in the world. Hopefully you follow your notes and etc. If you need some help on those story problems, holler at me. My Math Lab.